You're watching Discovery HD.
After traveling hundreds of millions of kilometers in deep space, after surviving a blazing descent through a dangerously thin atmosphere, humans have finally landed on Mars. It is the most dangerous mission in the history of space exploration, and the most compelling, the search for life on another planet.
Are there others out there, and what are they like? Are we the descendants of microbes that somehow traveled from Mars to the Earth?
Every minute on Mars will cost $500,000, but the real price may be measured in lives.
If we're going to find life on Mars, it's going to be a very difficult search. We have to learn a lot more about life in extreme environments on Earth.
Around the globe, researchers hunt down the ultimate survivors, bacteria, clinging to life in the driest place on Earth, or the desolate frozen rim of an Arctic crater, or deep underground in the far reaches of spectacular caves.
Bacteria can be very resilient. Could they survive in the lack of an atmosphere, in the high radiation, the very dry conditions on the surface of Mars?
Life forms we may not understand, and perhaps should fear.
Any bacterial life that might exist on Mars really could be hazardous to the human population.
Could Martian microbes wipe out humankind? For the first humans on Mars, the race to find life may, in the end, threaten their own. Every day on Mars has deadlines and mounting pressure. Astronauts have to cover huge distances in a merciless, poisonous atmosphere. They must search for life on a seemingly dead planet. Water is the key ingredient to sustain life, but that disappeared from the surface of Mars billions of years ago. So astronauts will search the dry beds of ancient rivers and lakes. But where should they dig for those precious samples? That's what scientists are investigating in the Canadian Arctic near NASA's Houghton Crater Research Station. They call this place Mars on Earth because it has so many similar features. A perfect stage to rehearse the search for life on the Red Planet.
One of the most exciting things that you experience in a place like Devon Island is that every step you take, you are faced with a Mars wonderland, catching insights into how we might explore Mars and how to search for life there. So Mars has a vast canyon system with many tributary canyons. It's still a mystery as to how they formed exactly.
One theory is that they were formed just as they were on Devon Island, carved out by the movement of large bodies of ice. And there's another striking similarity.
We found astonishing resemblances between the valley networks on Mars and the valley networks that we see here on Devon Island, formed a long time ago by the melting of a large ice sheet that covered all of this land. And so we are wondering now if some of the ancient valley networks that we see on Mars might have been formed by ice sheets that are now gone from the surface of Mars.
But the most famous Martian feature of Devon Island is Houghton Crater, one of the best preserved large impact craters on Earth. If there's anything alive on Mars, odds are it's bacteria. Canadian Space Agency's geologist Gordon Osinski agrees. What he discovered here may change the way astronauts search for them in the thousands of craters that pockmark the face of Mars. At first glance, it seems impossible that anything could survive in this polar desert. But under 90% of the rocks are colonies of a green bacteria.
They're there because underneath this rock, they're protected from the intense UV radiation. It's a slightly warmer, wetter environment.
These bacteria are thriving today because 23 million years ago, an asteroid struck Devon Island, exploding with a force of 3 million atomic bombs. It blasted a crater larger than the island of Manhattan and deeper than the Grand Canyon. Boulders the size of buses were thrown 10 kilometers from the impact. Billions of tons of fractured rock were heaved up, forming these huge gray hills. all life in the area was vaporized in a flash. Every Martian crater was created in the same catastrophic fashion. But a few thousand years after the impact, a crater may actually be more suitable for life than the surrounding land.
Now this is a very interesting rock we have here. The impact event put basically bubbles into the rock so that life could invade there, so that these bacteria could actually survive by living about a millimeter or two within the actual rock. On early Mars, the underside of rocks and within the cracks within the rocks would be a great place for life to thrive, where it's protected from the intense cold and the intense radiation.
Life probably reappeared in Houghton Crater around one of these strange orange mounds, the remnants of hot springs which formed after the impact. There, bacteria found two key ingredients for life: water and warmth. The same might have happened in Martian craters.
The structures that we see in here are indicative of life, and maybe on Mars, hydrothermal sites will also be some of the best candidates to search for life. And one really great thing we've been able to do here is to map out where in the crater these vents are found. And amazingly enough, they're just around the crater rim. So on Mars, you could just send a rover or a human to the outer edge of these craters to look for signs of these hydrothermal vents. The closer you look, you can find life surviving in all these places where you never would have thought it could survive. It's going to be exactly the same as the first astronauts on Mars. It's just going to be amazing.
Most scientists believe Mars was warmer billions of years ago and its craters filled with water. If so, they'd be an ideal place for life to take hold. Water has now disappeared from the surface of Mars, but fossilized Martian life might be buried at the bottom of those dried-up lakes.
What would be preserved at a site like this? What would we have to look out for if we were to search sediments on Mars?
The answer may lie at the bottom of British Columbia's Pavilion Lake. For years, researchers like Darlene Lim, a Canadian expert in ancient lake beds, have been diving here, studying some amazing 10,000-year-old carbonate formations. These coral-like spires could be living examples of some of the oldest forms of life on Earth, and also possibly on Mars.
The first time I saw these structures, it was completely shocking.
Carbonate formations are found in many lakes, but those discovered here are among the largest in the world. Structures like this can only form on a planet with large bodies of liquid water. Finding similar fossilized reefs on Mars would prove it was once warm and wet enough to sustain life. Problem is, so far, space probes have been unable to detect large amounts of carbonate on Mars.
Maybe it is that we're just not looking for them properly.
So today, for the first time, a large fragment of the carbonate reef is brought to the surface.
Holy cow, that is so good.
This one doesn't look like it's stirring up nearly as much.
Yeah. Beautiful. And it's an amazing piece.
Samples are taken for shipment to laboratories where they'll be analyzed and scanned so future space probes will know exactly what to look for. The carbonates in Pavilion Lake may provide other clues as well. Researchers suspect these huge structures were built by microscopic organisms related to some of the most primitive life forms on Earth, exactly the kind of bacteria that might have colonized ancient Martian lakes. Fossilized bacteria are tough to identify, but the Pavilion Lake carbonates reveal the tiny telltale signature they leave behind. If astronauts discover matching microscopic structures in Martian carbonates, they'll know bacteria once lived there. And even more astonishing, that those Martian carbonates were built by the same microorganisms as those found on Earth. It could mean that Mars and Earth are distant cousins, evolved from the same spark of life.
We would simply be members of the same family, just spread on two planets.
Billions of years ago, Mars might even have looked like Earth. But now it's just a poisonous wasteland. Could any Martian life have survived that radical change? The answer might be buried in the driest desert on Earth. The surface of Mars is blasted by life-destroying radiation. The atmosphere is lethal and frigid, as cold as the lowest temperature ever recorded on Earth. How could any life survive in this barren soil? When the Viking probes went to Mars in 1976, they found no evidence of life. Were they right, or did they miss something? The answer might be buried in the Atacama Desert of Chile in South America.
This is the only place on Earth that the Viking lander could have landed, scooped up some soil, and not detected evidence of life.
NASA researchers like Chris McKay know there are traces of life here, but those elusive bacteria are as tough to find here as on Mars.
The way I like to describe it is we have a little patch of Mars here on Earth.
About 2/3 the size of Italy, the Atacama is the oldest, driest desert on our planet. Hardly any rain has fallen here for the last 10 million years.
The Atacama Desert is 50 times drier than Death Valley. Mars is more than 50 times drier than the Atacama. But in the past, Mars was maybe wetter than the Atacama even.
Most scientists now believe there were bodies of water on Mars billions of years ago, maybe giving life an opportunity to take hold. Just as it does now around the few oases that defy the Atacama. But the further we travel away from these oases, the more the desert takes back. So it's a kind of living portrait of what happened on Mars as the water disappeared. This offers clues about how life might have adapted as the red planet became a desert.
So we have little islands of life that are surviving. And one of our goals is to try to see how those islands are shaped and also see if we can recognize it from space. And we'll use that knowledge to map out Mars and search for life on Mars.
As a guide, researchers map out life in the Atacama by checking the organic content of thousands of soil samples.
So we will collect samples that are meters apart, then we'll collect samples that are hundreds of meters apart, kilometers, hundreds of kilometers. We'll try to see soils that have life, soils that don't have life.
Soils rich in life are easier to find at night. That's because some bacteria and organic material turn fluorescent in ultraviolet light.
Let's turn off the lights. Look at all these colors. This is really beautiful.
Look at that brilliant orange.
That we might imagine this being used on Mars. A rover going out at night, turning on its UV headlights and searching for fluorescent minerals and maybe even organic material in the Martian rocks. Okay, well, it looks like this. On Earth, we find little oases of death in a planet that's alive. On Mars, we'd be searching for little oases of life on a planet that's dead. The boundary between alive and dead is the same.
The instruments astronauts will need to locate pockets of life on Mars can be tested in the Atacama. That's where this place comes in. The Yungay Research Station doesn't quite look like a science lab. But inside is state-of-the-art equipment for detecting life. Scientists hope these probes will soon be flown to Mars. But first, they will be given a test run of the seemingly lifeless soil of the Atacama. The dirt samples go into what looks like an espresso machine, except this one operates at huge pressure, flushing out the tiniest trace of organic material.
Those biological molecules you're looking for won't be released from the rocks unless you do those extreme things with water.
Canadian chemist Alison Skelly then puts the droplets into a probe which can identify the chemical building blocks of life.
So we're targeting the amino acids, hoping that if there was life on Mars, even though it's dead, they'll be able to see that amino acid signature.
The probe, 1,000 times more sensitive than Viking, manages the impossible. It finds life where none was detectable before. If a Martian soil sample produces a spike like this, it could be the first sign the astronauts have discovered life. The data will probably show this organic material to be millions of years old. But there's a slim chance the astronauts might have found the ultimate prize: live bacteria. It's an idea that comes once again from studying death in the Atacama.
In this desert, we find something that we think is also occurring on Mars, which is the production by sunlight of chemicals which are constantly attacking the organic material. The bacteria that we find in the soil here have developed mechanisms to repair that damage very efficiently. So on Earth, we have a bug that we think is the superbug, very resistant to dehydration and also resistant to radiation. But it may be that we'll go to Mars and find real superbugs that have learned to survive the dryness and radiation on Mars. This might be very exciting.
But those bugs will be well hidden. As the surface of Mars turned to dust, bathed in radiation, bacteria probably migrated underground.
My guess is that in any case, when we find life on Mars or evidence of life on Mars, it'll be underground. Moving below ground, there's a zone in the subsurface where there might be water and there might be life.
To find living cells, astronauts will have to drill deep under the surface of Mars. They'll also need vehicles to get them to and from the site. Will their technology be up to the challenge? Mars has a surface area as big as all of Earth's continents combined. Astronauts will have no choice but to make long-range and therefore perilous expeditions. On Devon Island, a research team is trying to figure out the logistics of those hazardous missions. So Pascal Lee and two former NASA astronauts, Mario Runco and Jeffrey Hoffman, are planning an expedition to the unexplored north coast of Devon Island. They want to take a closer look at the Mars-like gullies that have long intrigued scientists. Were those channels on Mars also carved by running water? Extraordinary new pictures released by NASA show that some of these gullies appear to have been created as recently as a few years ago. And where there was water, there might still be life. Tests done on Devon Island established that an astronaut wearing a cumbersome spacesuit with a limited supply of oxygen can't roam more than a few kilometers from his landing site even with the help of an open vehicle. That's why the team will travel on board this modified Humvee, simulating a trip in a pressurized rover. Inside a pressurized rover, the astronauts can travel for days in a short-sleeve environment. Only when they reach their destination will they need to put on their spacesuits. During the trial, the team learns an important lesson. To prevent the large Humvee from getting stuck, it needs to be guided by at least two scouts. One is way out in front, breaking trail. The second is closer, showing the exact path to follow. And in this case, keeping an eye out for roaming polar bears. On Mars, robotic rovers could do the job identifying landmarks and obstacles with the help of satellites. Nearing the gullies, terrain becomes so rough, the explorers will have to proceed on individual rovers.
Careful as you lead us over that.
And there's another problem. They can't be sure exactly where they are.
That's the small lake in front of us, and there's the gullies which we can't see.
Compasses don't work on Devon Island because it's too close to the magnetic North Pole. So the team must rely on aerial photographs.
Yep, it sounds about right. The gullies are 2 kilometers away.
A compass will be just as useless on Mars because there's no magnetic field. Astronauts will eventually rely on GPS. And if that fails, they'll resort to satellite pictures. Four hours after leaving the research station, our explorers finally get to the ridge of the massive gullies. They look just like the ones on Mars, with a triangular crevice on top and a narrow channel that runs down to a heap of debris. Devon gullies were cut slowly over time by melting snow and ice. That water created little oases of life for bacteria. Maybe the same thing happened in the gullies on Mars.
So an early result from this project, it seems like what's at the bottom of the gully is richer in microbial life than what's near the top.
So when astronauts search the gullies on Mars, this is where they should look. Another lesson is learned from this trial.
The idea that you're going to go 100 kilometers in your spacesuit in one day is just not going to happen.
A pressurized rover may be needed for trips as short as 10 kilometers. As the team is about to leave, a spectacular find.
We were walking around, and one of the people in the group, Pascal, just happened to see this pattern. This is an incredible fossil. You don't send robots out to find fossils because they don't have the situational awareness that a person does. So when we finally do get people on Mars, the rate of discovery is going to go up just immeasurably.
Everywhere there is liquid water on Earth, there is life. Might there have been life on Mars? Might there even be still life on Mars today, wherever liquid water might be present, perhaps deeper down?
Since Mars is so cold, liquid water will most likely be found thousands of meters underground. On the barren rim of Houghton Crater, a prototype Martian drill is already being tested. The Roughnecks are researcher Brian Glass and his team of scientists. On Mars, power will be precious, so this drill uses only as much energy as a couple of light bulbs. Of course, no one promised it would be fast.
How deep are we at the moment?
206.1 centimeters.
My drill took 3 days to go 2 meters into frozen, broken rock. Well, we're already more than double the depth of the hole in the breccia we drilled last season, so that's a step forward.
Drilling on Mars will be a slow process, so the next challenge is to design a rig that can operate on its own without astronauts watching over it.
What my project does is, in some sense, it replicates a human drilling team. So we have software that does that. It listens to the drill, what noise is it making, how the shaft wiggles as it goes down, just like a human would.
When the drill detects a problem it can't handle, it calls for help. Overall, the drill performs better than the team had hoped. A small victory that may help unlock Mars' deepest secrets. Space probes have already detected large amounts of underground ice on Mars. There might even be pockets of liquid water about 2 kilometers below the Martian polar caps.
It's the sort of environment one might actually find living creatures if we were going to find them there.
If the drill hits water, it could gush out in a snowy spray, freezing instantly in the Martian supercold air.
The most appealing argument for life on Mars is that it would have followed the water.
So we have to make this work. Find out what's there, find out if there's life, help figure out our own place in the cosmos.
If the drill fails, the astronauts will set out on their boldest expedition to find life at the bottom of a Martian cave. The burning lava fields of New Mexico. 5,000 square kilometer maze of razor-sharp volcanic rock. From microbiologist Penelope Boston, this is where we can learn more about Martian underground life.
We know that Mars is not internally dead, although it's a less active planet than Earth, and there may very well be volcanic hotspots spread in many places around the planet.
Volcanoes can spawn underground rivers of lava that leave behind huge tunnel-like caves. They're called lava tubes.
So we're standing here on this lava bridge, which is the remains of the roof of this tube that once filled this entire area.
On Mars, because of the low gravity, the tubes are between 2 and 10 times the size of these tubes.
Martian lava tubes can be over 60 kilometers long and wide enough to accommodate a city block.
Those tubes may actually contain organic chemicals, and most significantly, possibly organisms.
Penelope Boston and her party finally reached the most impressive lava tube in the area.
All right, watch your footing, kids. A lot of loose breakdown here.
As our explorers descend, the air gets colder with every step.
But the minute we get into the entrance of the cave, it's almost like going to another planet. The walls are saturated with water. The temperature is right hovering around the freezing mark.
But there are life forms that call this place home.
The bacteria are just everywhere. All of this white material on the walls, shining with water droplets. You can see it all over the ceiling, all over above us, and it's easy to get to.
Using sterilized tools, the researchers take small samples of the bacteria.
When we actually look at them with electron microscopy, each one of these little dots on the wall is like a major metropolitan city for people. It's really an entire civilization, if you will, of these little tiny guys. And these organisms can derive their food from the bare rock surfaces. So they're essentially acting as rock eaters. It gives us a fresh perspective on what to look for on Mars.
Exploring a lava tube on Earth is dangerous. On Mars, it could be suicidal. Many rovers equipped with cameras and life-detecting sensors could be sent in first, establishing an underground communication network. But sooner or later, the astronauts will want to see with their own eyes.
Lava tubes dating back to the time when Mars was very wet might be really excellent locations to search for life. These protected from the harsh radiation exposure, warm because of the activity of volcanism nearby, would work really well for the proliferation of some form of microscopic life.
Those organisms may even, in fact, be alive today because abundant biology can be run with energy sources that are disconnected from the sun. And so that's a very exciting possibility.
The first extraterrestrials the human race encounters might live in a drop of water, eating rock on a Martian cave wall. It would be the most stunning discovery in the history of space exploration, especially if this life turns out to be different from life on Earth.
Then we would be in the presence of a form of life that would have started independently of life on Earth.
So that we know that in our own solar system, life started twice. And if it started twice in our own backyard, then we know that the galaxy is full of life.
But any form of alien life taken back to Earth could be a biological time bomb.
If we bring back a rock sample from Mars to analyze, we will want to be extremely careful to make sure that nothing associated with that rock really could be hazardous to the human population.
We don't know if Martian life and Earth life can live together. So we have to be careful until we understand better.
Let's make sure that we protect ourselves as best we practically can. Let's isolate and be cautious.
After an epic 18-month stay on Mars, the anxious crew prepares to come back home. There is one last challenge: Martian weather. If satellite pictures reveal a major dust storm is brewing, they're in trouble. Fueled by hundreds of giant dust tornadoes, Martian storms can whip up 400-kilometer-per-hour winds, quickly spreading over areas the size of continents, and generating as much electrical activity as 2,000 thunderstorms.
A dust storm can wreak havoc for the last generator, the last solar panel, the last chip that controls your computer system. I mean, you can imagine all sorts of irrevocable damage.
Comlin's down again.
A monster storm could rage for months, but the astronauts must blast off Mars as scheduled. Any delay could be disastrous.
If you don't launch within that launch window, you can't catch up with the Earth. It's as simple as that.
Leaving the astronauts stranded on Mars for another 2 years is effectively a death sentence. Whatever the Martian weather is like, the ascent vehicle must work perfectly, or it may become the most expensive tomb in history.
Hey!
56 million kilometers from Earth, 6 pioneers get set for the long journey home. And they know that leaving Mars will be far more dangerous than it was getting here. For the last 18 months, the lander has been parked in a deep freeze with an average temperature of minus 63 degrees Celsius. Cold starting the engine may be almost impossible, risky at the very least.
Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
In January 1986, unusually cold weather in Florida contributed to the failure of a seal in one of the solid rockets attached to the Challenger, causing an explosion shortly after liftoff. With the same type of oxygen-hydrogen engine and the bitter cold on Mars, the ascent vehicle could suffer the same fate.
You've got to make sure that the system is, if you will, contained and resilient to the local environment.
The extreme cold is just one of the problems. Martian dust is 10 times as fine as talcum powder, which means it can easily contaminate sensitive computer systems and compromise pressure seals. Problems only the crew can fix because there's no backup on Mars. Dr. Jim Longuski, a 9-year veteran with NASA's JPL, now teaches astronautics at Purdue University.
Now, when you compare, say, the launch of the shuttle or even the Saturn V that launched Apollos, we had hundreds of people on the ground monitoring all the systems, giving all the computer support, and if anything went wrong, they could always shut down the launch and run a few technicians over there to examine the vehicle, replace a part, and get them going.
Alone and often out of touch. A message from Mission Control to the Mars crew takes up to 11 minutes just to get there. question is not if there will be trouble, but when.
Copy that. Verify ignition procedure. You try as you might, you train as you might, you build as you can to try and mitigate that risk. However, let's face it, things can go terribly, terribly wrong.
The last-minute snag almost stranded Apollo 11 crew on the moon.
While I was down there on the floor, I was looking around, and I saw a broken circuit breaker. So I started looking along here, and it was the engine arm circuit breaker. Now, that's the one that has to be in to get power to the descent engine and power to the ascent engine, which we needed to get home.
And without an ignition switch, they weren't going anywhere. Houston's solution was to use an ordinary ballpoint pen to toggle the switch and ignite the engine.
And you're cleared for takeoff. Roger.
When it came to the Apollo program, we had to consider what happens if something goes wrong and we can't get them back.
Getting airborne is just the beginning. The timing must be perfect to make the rendezvous with the Earth return spacecraft waiting in orbit. The mothership will be shooting around the planet in an egg-shaped orbit at speeds varying from 1,600 to 16,000 kilometers an hour. That's up to 17 times the speed of a jumbo jet. Everything has to work the first time. The lives of the crew will be riding on it.
If that rendezvous should fail, not only does the mission lost, the crew is lost.
If they make the rendezvous, the crew then sets off on the final leg of a journey that started nearly 24 months ago. But they're still not free and clear. There's always the danger of a microscopic but deadly stowaway.
We really don't know if bacteria have existed or do exist there. Can they cause disease in humans? Can radiation affect the bacteria that we bring with us in a manner that non-disease-causing bacteria all of a sudden become disease-causing bacteria? All of that's unknown, so we need to protect that. And then ultimately, we need to protect Earth.
If the astronauts find microbial life on Mars, it must be handled with extreme caution. The spacecraft interior makes an ideal breeding ground if a rogue organism gets loose.
If they run into something alive on Mars, you're not surprised by it later on, only after they come back to the Earth.
After the moon landing in 1969, NASA worried that the astronauts might bring back an exotic microbe. So they developed the mobile quarantine facility, a highly modified vacation trailer with an elaborate air filtration system. Recovery engineer John Hirosaki handled the moon dust cleanup.
The fear was that if you had extraterrestrial sources of possible biological contamination, you could have a runaway contamination of the Earth's biosphere. You can get some very hostile invasive species occurring that you really do not want.
This quarantine facility was state-of-the-art in its day, but the crew returning from Mars will undergo much tougher scrutiny.
As the Planetary Protection Officer, you have to be a biocop. You're making sure we don't take Earth microbes to other places where they might grow and thrive. And if we bring something back, we want to make sure it doesn't contain the Andromeda strain.
Even so close to home, the Mars explorers are still not out of the woods.
If the crew members pose an unsupportable threat to the Earth, then they would have to agree that returning to the Earth in that condition is impossible.
The astronauts would wait in Earth's orbit or in a quarantine facility on the moon until doctors were certain they pose no threat.
Oh, that view is tremendous.
Then, having survived the mental and physical strain of an epic journey, the astronauts face one final challenge: picking up the pieces of the life they left behind.
3 years of your life you've been away from Earth. If your kids were 10 years old when you left, they're going to be 13 when you come back. Leaving your family, your loved ones, the whole environment of the Earth, the impact of that is going to be huge.
The costs of a mission to Mars, both financial and perhaps personal, will be staggering. But that's the inevitable price of becoming an interplanetary species. The real question is whether the Red Planet can support a human colony and a new way of life. So begins the most dangerous and exciting adventure in the history of human exploration. Engineers and astronauts have overcome monumental obstacles, but the next job will make those seem like child's play.
At a certain point, the question is going to open up. Can we make Mars a fully living planet? Can we transform this desert into a fully living world like the Earth?
It sounds like science fiction, but a growing number of researchers believe it just might be possible to turn the Martian desert into an oasis.
Terraforming is a word that was defined first in science fiction, and it means just what it sounds like, terraforming, making like the Earth. But now we realize actually that for Mars, terraforming is possible. The fundamental challenge in making Mars a planet for life is warming it up. Well, we know how to warm up planets.
There are two big theories on planetary warming. The first, we've already stumbled on, using greenhouse gases to heat up the atmosphere.
What we'd have to do on Mars is what we're doing on Earth, produce these gases in factories.
Hundreds of solar-powered factories will be set up on Mars and could begin to drive up the temperature within 100 years. The second theory on warming up Mars is literally out of this world. Gigantic mirrors the size of Texas floating in space to redirect and magnify the sun's rays.
That sunlight would add energy to the polar regions, warm them up, which would in turn produce carbon dioxide gas, which would add to the atmosphere and make it thicker.
It will be a painfully slow process. Just melting the ground ice could take several centuries. And even when Mars is finally warmed up, the atmosphere will still be poisonous carbon dioxide. To sustain human life, Mars will need a massive dose of oxygen.
The only way we know how to make oxygen over a whole planet is with plants. So one of my interests is finding the plants that will be the first Martian pioneers. These little guys growing under the stone are actually making oxygen. These organisms can change a world. Billions of years ago, Earth didn't have any oxygen. It was organisms like these that produced the oxygen that got biology started on Earth. I think they can do the same thing on Mars.
If humankind finds a way to transform Mars into a living, breathing planet, it may become the new world for the first wave of transplanetary immigrants.
And this can happen once we have mastered the use of Martian resources. We'll be able to build more habitats. We'll be able to build domes, perhaps 100 meters in diameter, in which people can live in.
I think Mars is a place we could go and live. I think we can build the systems to be safe. We can learn to make it a habitable environment, the way we've started to learn in the Antarctic at the South Pole.
Eventually, colonists might even be able to live comfortably without spacesuits or breathing equipment. It sounds far-fetched now, but the day may come when Mars will serve as Earth's lifeboat.
The dinosaurs were wiped out by a planetary impact, probably a comet or an asteroid. And when you see the devastation that was caused by that, wiped out God knows how many percentage of the species on the planet, those sort of things can happen again. And so if you want to look at the noble image of trying to have the species survive beyond just our children and grandchildren, a lot of people would say we have to get off this planet and establish a foothold somewhere else.
Since the beginning of time, humankind has felt compelled to explore, driven to open new frontiers. No single nation or people can hope to reach Mars alone. It will take an international effort by governments all over the world. The quest for the Red Planet is the first page in a new chapter of human history.
1,000 years from now, people remember the late 20th century, early 21st century in ways we can't imagine now. But they will remember the big things. They will remember if people got their act together and got to Mars. They will remember if we found life around another star. Those are the things worthy of the space programs of the world.
In the future, we may look back on the early Mars explorers as the pioneers of a new frontier in space. And the Red Planet that once seemed so cold and distant will be full of promise, a place like Earth we may one day